Skeet is apparently, this is an obscure reference that I didn't make actually, is sort of a form of monasticism where you're not quite a hermit, but you're not quite a monk, right? Like you don't have a big-ass monastery where everybody hangs out and follows a rule and lives together, but you're not like out sitting on some pillar in the desert. So you have this sort of vague relationship between a centralized or at least upstream church and your own sort of private domiciles. And this is relevant to the idea that Davian expressed to me a few months ago, which was like, it would be really cool if I could have like a git checkout of hackage. Because, well, okay, hopefully that sounds cool. But like all of hackage, because we want all of the things. And we want them now. And so I thought that was cool. And so we started working on this thing. And this thing is at the point where we can talk to other people about it, and that's what I'm doing now. So here's a neat thing we made and are working on, and we're interested in other people being excited about it and telling us what they think and all of that. So package repositories, they exist in more languages than just Haskell. And in theory, if you were to use a language that wasn't Haskell, for some reason, you might be familiar with like CPAN or PyPy or things that will not be named here that rhyme with Raven, say. And they all work the same way, give or take, right? You go and you get some information about like what's available, or you say, hey, I want this version or whatever. The system in aggregate knows about all of this stuff. Maybe it has manifest files, maybe it has POMs, maybe it has, I have no idea how CPAN works, and I'm very happy that way at the moment. But you go off and you get it, that information, and you can use that to say, oh, give me this package, give me that package, right? Cabal will go off and solve, how can I have all these packages working together according to whatever constraints you gave me. And that's how they work, right? We're all familiar with these things. I'm not trying to say anything confusing. So this is a funny slide. One of the things that it turns out that some of them do and some don't is this notion of package sets. That was another interesting thing, right? We have hackage right now, and hackage is all the packages. But if you look at Debian, they have Debian stable, right? And Debian stable has packages from 7 years ago because it's stable, and Debian testing has packages from like 5 years ago because it's cutting edge. But they're different sets of packages and different overlays of packages on a larger group of all of the debs that you could possibly have, right? So we're thinking about this sort of as saying, well, if you took every deb that's been published to sorry, I don't speak Debian super well either, but the greater Debian infrastructure, you can slice out certain ones of them to provide sort of a view on like, we like these packages but not those packages. Stackage actually is an example of this, if you're familiar with stackage. There are other differences, but that was the interesting one that we're going to pick on because we do that. And it's kind of in the news lately. I don't know if you read the Reddits or the Haskell Planet thing or whatever, but people are interested in kicking hackage in the teeth a little bit, getting things a little better, more security, more distribution, more other things I'm forgetting. What else do people want out of it? Crypto. Sorry, more security and more crypto, because more crypto is always good. Yeah, I mean, you can read. So these are other problems. Really want to talk about what we actually made, which is, of course, it's Haskell, right? So we started by building a package management system. And then we said, let's make a system for making package management systems, right? Because clearly what we need to be is initial in the category of package management systems. And so that's sort of where we started to work with it. And we have it, at least for hackage so far, and we're starting work on Ruby gems real soon now. It's a relatively sparse, kind of simple, pleasant interface, right? So what can we do here, right? We're gonna have this big repo thing. Please yell at me if things are getting poorly described. What can you do? You can add packages to it. You can label packages. This is like the type class. It's just written in English. We use the word label for adding to a package set. So you could say, oh, not only did I add the most recent version of pandoc, but also I'm going to put pandoc in my Debian stable, my Debian unstable, whatever. And I'll have it there. You can pull packages out, so you can say, hey, give me pandoc version 7, and it'll say, okay, sure, here's a handle to it. And I guess we're talking a little bit about programming. The handles are opaque, so we're using Git as our backend, and that's our sort of inaugural backend. You can use other backends if you want. We're spelling everything in Git, and we'll talk about how we spell it in Git. But you could put you could just use a regular file system. You could, I don't know, maybe use S3 or something. Rados, the sky's the limit as long as you're not making me do it. And similarly, get the packages, find out what the package sets are. So that's our interface. And the goal, right, again, imagine if we had kind of a Git repo that was hackage. Well, it turns out we get neat stuff. We get clones of hackage on your machine for cheap. We get things like, I don't know if you've ever worked at a company where they didn't want to open source every single package you made. It could happen. Sometimes it does. And it's nice to be able to add your packages to the package management system that everyone uses without making it so that everyone can see them. Hackage isn't really good at that. Right, like the hackage server now, and there are a few variations on this, and I'm not up to date on the specific details of every one, but you have to go and set up your own hackage and do some kind of weird, I don't even know what you do, but you set up your own thing, right? This is a place where like the Java people have done a lot of work to achieve, I'm going to go to my local Maven repository, and then Maven will look further up to Maven Central or Clojars or whatever, jar repository is your favorite repository of jars. If I keep saying jar, it'll lose all meaning. But it turns out one of the things we can get by making making everyone, in the Git sense, everyone is master, right? Everyone is the repository, is that you can start adding things to your own repository or to your organization's repository, and there's no reason why those things need to get pushed back up to hackage if you don't want. But they can if you want. And indeed, I mean, it might be a little cute, but doing it with Git turns out to make a lot of this work very nicely.
What about like I assume this handles I'm working on my package that I will push eventually, but it's not ready for public view yet because it's too in development.
Yeah, let me, I found out today that there's apparently a place on hackage for that too. Just today I found out about that, but that's a separate detail.
Okay.
I don't know how that works at all, so I won't say. What I will say is that to be clear, we are not storing your Git repo of your project, right? We're not storing your development history. We will be storing your release tarball history, right? So you're going to make a source tarball, right? And it's going to have whatever it's going to have. We'll store the history of every version you release. At least that's how we do it right now.
I mean, in theory, you could actually link the two repositories and have a development repository be a subsection of this if you really wanted.
You just run into the Git submodule problem, or something like it.
Not as a submodule.
You're going to do a filter branch over?
No.
Okay. Apparently you can do something else.
Yeah, I'm not sure you'd want to.
You could work hard and make other things happen. That's not the way we did it.
Yeah,
not the way I think about it, I think, is really the problem. And though he's not talking, he's also responsible. Yeah. We looked at hackage a bit. I don't know when these are from, but probably earlier today, maybe yesterday.
About 3 weeks ago. This is what I imported. This is what's in Skeet hackage currently,
Got it.
which is about 3 months.
Oh,
weeks
sorry.
out.
We built this and we've managed to make it work. It's been dog-fooded a little bit. It's slow, but it actually does work for what it's worth. And when last we imported all of hackage into a Git repository, it was 54,000 packages, a massive quantity of stuff when compressed. It turns out that if you XZ it all together, it gets small, but Git's good at compressing the redundancy because you don't want 19 gigs stored on your machine. That's a little too much. Did I miss 2? No. Okay. So I'm going to talk a little bit about how we shove it into Git. I don't need to explain why we use Git. People like Git, right? Everyone's like, yeah, Git, right? We should use it for everything. We're using it for this. We get really, really cool screenshots from GitK when we do it because of the way we've embedded things. So you can go back and look at that later if you like. But this is effectively the structure. And in fact, largely the format for our commit messages. So we'll have a branch where meta variable at for this is a for package sets or labels or whatever you want to call it. That's going to point to a commit. The commit is, does everyone speak Git internals well enough for me to say this points to a commit, that points to a tree? I will take your silence as deafening comprehension. This branch is always pointing at a merge of the last version of every packet for all, right? That's sort of grandfathered in as every package. But you could have, my private, cool, unstable repository. It'll hold the previous label, or the previous commit, like this, and the most recent package you added. Does that make sense? So every time you add a new package, we're going, and to a label in particular, we're going to take the label, have it point at its last revision, in the Git sense, plus the new thing you added to it. So it's a linked list, effectively, spelled out in Git objects. What is this thing?
That's the package command.
Right. When you add that's when you add it to a label. When you add the package, we store some metadata inside of it. I have no recollection of what. Oh, that's the other stuff.
Yeah.
Right. Sorry. This thing is an extremely poor representation of, because Skeet is a library for making these things, you can put whatever metadata you want. It's a YAML document, right? So you can shove whatever you want in here as the metadata for your particular flavor of package repository. So if you need, I think RubyGems needs to keep some information about dependency versions. So you would expect that might get stored here. And then Skeet is still providing you with the ability to sort of have this linked list superstructure that I'm describing. But you get to sort of say, here's all the metadata that I need to actually reconstruct the sort of front end utility of RubyGems or CPAN or whatever else. That's about all. I think I've banged on all of these points pretty hard, right? Except this one, which is important. We did this. The Git repo is like a gig. It's a little bit more than a gig now, but when we started, it was less. But people added too many packages since when we started. So, I mean, success, I guess. But we're really close to a gig, and we're just too honest to say less than a gig anymore. Because we're good people who you should trust. Oh, pulls. We never talked about pulls. Now you can git pull your index.tar.gz. Which I don't think currently is how it works. So right now, every time you cabal update, it goes off to hackage and downloads a tarball that contains, I think, at least one line for every single package.
It actually contains the entire cabal file for every single package.
Okay, fine.
And
so
that's why cabal update takes minutes sometimes.
So I don't know if that's on the recording. I'll just say it again in case it didn't. When you do cabal update, it downloads every cabal file from every package, for every version, for every revision, for those of you who know about package revisions, on hackage, I think. Maybe the revisions are wrong, but at least all of those, which is a lot. And it turns out that, git pull can, send deltas instead. So that's a thing that's nice that we get too. Oh, I didn't talk about pinning hackage as a submodule. Debian really likes this. I'm always afraid of submodules, but you can set up, one of the nice tricks that works with this is that you can just make a submodule that points to a particular SHA that represents, here's hackage as of Tuesday. And then when you, git submodule update or whatever it is, it'll download all of hackage and all the objects for same into that little subdirectory, and you can have a nice self-contained, there's hackage that sort of works nicely with an external ecosystem. You can update whatever SHA your submodule is pointing to, which might be more of your private stuff or might be some of the public stuff or any sort of combination of the same. My feelings on this is that it's sort of a novel approach to Cabal Freeze or Bundler, if you're familiar with Ruby, or horrible, horrible sins involving putting the structure of a Maven repository in your revision control system and just checking it out every time, because that happened. And that's about all, right? This is a little bit of an advertisement for the work we're doing. We think it's pretty neat. The projects are available. You can look at the Skeet group, which has a bunch of the stuff we're working on. Two of the important bits are Skeet, the backend, and Skeet. Did you change the name to Skeet Hackage?
Oh, no, that should be House.
Hang on a second. Yeah, you can go, you can look at it. There's some other projects in there. We have had to patch a few upstream packages, so we're not like all GitHubbed and out in regular hackage yet, because we have our own version of some Git stuff, and there's another package that we had to mess with a little bit, and I don't remember which it is at the moment. Faster. Apparently, the evil empire is not sufficiently fast. That was going to be cool. Oh, right. And we're done. Sorry. Right. And then I have appendices if you want to talk a little bit more about the encoding. You never added the type class. So yeah, no, that's what we've been up to. Questions? No. Go.
So you said that you made something that's more meta that can be used to create another system, another repository.
Sure.
So what is the division between the code that is reusable and the implementation code that you use to create a package?
Right. So Skeet proper doesn't know anything about front ends. I say that as if we didn't have one particular front end in mind, but that's the intent.
Particularly, it doesn't know package formats, for example. It doesn't know the metadata associated with packages. That list of operations that basically define a software repository are basically what it understands. And then understanding those packages is what's filled in by...
One thing that wasn't on there is dependency resolution. So
right, that fits in the front end. Right. And they handle dependency resolution, which really, hackage doesn't. Cabal handles that. It's told the dependency information that's part of the package, but hackage doesn't really deal with that.
Cabal is dependent on package.
Right. Now, Ruby is a bit different. Ruby Gems actually does, and Rain Hendricks is kind of working on a Ruby implementation for this, Skeet Ruby, though there's no code actually released for that at the moment. And that's one of the reasons that you see those extra data areas in there, because Ruby needs some of that extra tracking that Cabal files don't.
Okay, so the other question is, where is the metadata stored? Is it also stored in Git?
Yes. There's two locations. There's the git commit for the package. When there's static metadata associated with the package, it's stored in the package edition commit in that YAML thing that you saw. And if you go back to the commit thing.
That's what, the image?
Yes. Yeah, right there. Go back. No, the slide you were on before. This. You'll see here, there's E, Engine.io, Growler, the version, and then Cabal.
Okay.
This directory is actually a key value map of key to byte string. Now, in the Haskell case, which is what I presented here because I presented real data here, the only key and value are the Cabal file. But there can actually be other things added in here. And this is actually mutable metadata that can change over time. And in fact, it does in the case of Haskell, because there's something called package revisions, which you're probably all not familiar with, but it's basically how HVR manages to keep everything on a hackage building for you. Because people are really sloppy with their bounds on Cabal files. And sometimes they were not sloppy, but it turns out you can be less conservative.
Package revisions are common in things like Debian.
Package revisions in Debian are a bit different than they are in... Because package revisions in hackage don't actually change any package files, just the Cabal file metadata.
Just the metadata.
Right. There's this thing called a revision in hackage that is mucking about with some of the metadata for a package so that things will continue to work nicely.
And specifically, the thing you're allowed to edit, really, not technically quite that restrictive, but is basically the dependencies and the version constraints on the dependencies. That's what you're allowed to change. I think you're also technically allowed to change the maintainer, and if you have enough access, you really can actually change any of the Cabal file. Hackage just won't let you do it.
Right.
But if you have root, you could go in and change anything in the Cabal file technically, and Cabal would work with it just fine. So we store the Cabal file separately in this key value map, and you could store other things, which allows you to expand the front end.
There are actually, to the modularity question, there are two dimensions of modularity. Skeet in the sense of just Skeet, this guy, provides a type class for storing these packages somehow, right? And that's what that was what that thing that was a type class but was written in English was. You could come up with, if you're super obsessed with like monotone, you could go off and implement a monotone backend maybe. And that would be about how you storage, right? But and then, in theory at least, the Haskell package front end could be using your monotone backend if you want, because it's up against Skeet, right? So Skeet is here's the interface for building a distributed package system thing, and then you can sort of front end that however you like.
And we've actually had a few backends. The one that kind of won out was what we call Git Fat, which is the embedding we showed. We've had other embeddings in Git playing with purely functional data structures and such of different natures that have different trade-offs. We ended up liking the trade-off that Git Fat ended up being, which is a combination of what we call Git Deep and Git Wide, which is which basically combined this wider package set labeling area and the package in the list and such. We've also, to keep ourselves honest, we have occasionally had a file backend that just stores stuff as the current state in a file system implementation to make sure that we don't leak the fact that it's Git that we're currently using.
And that's for testing.
Sorry, what?
You have that backend for testing?
Yes.
There are times when that backend may be a really, really good way to do things. For instance, you might choose that backend if you were CTAN, was it?
I don't remember.
You could imagine having a file system backend that really CTAN is, here's a giant, the tech archive network. Here's a giant file system. Go and pick values off. It might not be worth your time to come up with a clever representation of that, because maybe you just sort of want to clone your web server down, and that would be a choice.
And there's other Git embeddings that you might want to have, which is like, for example, the FP Complete people have kind of a thing with hackage where they just have the metadata in Git and the tarball somewhere else. You can have that embedding here, where it's not a complete package, it's just the metadata that processes through your special package files. In our case, for the mere cost of a gigabyte, it's quite interesting to have all the package.
There are some neat things we kind of want to do involving like sort of archaeology on code bases that is greatly sort of served by having the ability to have all the stuff there very quickly.